All right, our final lesson with organic chemistry deals with combinations of all the previously discussed lessons. So our numbering priority is as such. Carboxylic acid should always be given the highest priority. Again, they're going to be on an end of the chain, so we'll always start by calling that carbon number 1. Alcohols then are the second most important, so always give them the lowest possible number, unless of course they're on the same chain as a carboxylic acid. Double and triple bonds come next, and followed by the lowest priority branches. So let's do some examples to see how this plays out. All right, here we have several things on this carbon chain. First thing I notice is that alcohol right there at the end. But I'm also seeing a double bond and a methyl group. So this particular chain has a lot going on with it. Again, thinking back to our highest priority, functional groups, that'd be alcohol, comes before double and triple bonds, which come before branches. So when we go to number this, we want to make sure that the alcohol has the lowest possible number. Since it's a terminal alcohol, that means on the end, we'll make sure that that carbon is carbon number 1. 2, 3, 4, 5. So we have 5 total carbons. Our parent chain will be a pent. Now notice again that we have a double bond, so it's not a pentane, it's a pentene. And when we name it, we make sure we put that branch out in front as well. The branch is on the second carbon, the ene is on the third carbon. So we call this 2-methyl. Again, the methyl group is on the second carbon. 3-pentene, the 3 belongs to the E and E. So that double bond starts on the third carbon. So 3-pentene, and then kind of weird, but to make sure we identify where the alcohol is. Again, that alcohol could be in a lot of different places here. To identify where that alcohol is, we put the number before the OL. So pentant 1-ol. 2-methyl, 3-pentene, 1-ol. Here's another example. Again, let's identify all of the substituents that we have. That's branches, groups, etc. One of the rules, perhaps you read it, was to make sure that the functional groups and or double bonds or triple bonds are always on the parent chain. Even if that chain's going to be a carbon or 2 shorter, you have to make sure that those double and triple bonds and functional groups are on the parent chain. So here's a double bond, and here's a double bond, which means here's a branch, and here's a branch. Okay, again, we've got some work to do to figure out what the lowest possible numbering system is. If we start at the top, we'd say 1, 2, 3, 4, 5, 6, 7. So we're working with a heptane chain, but if we number it the other direction, it might be a little bit lower numbering system. Let's give it a shot. 1, 2, 3, 4, 5, 6, 7. Okay, again, still our 7 chain, still working with a heptane. But when we go with red, we have a double bond on the second carbon and the methyl group on the second carbon. When we go with the blue, we have the double bond on the second carbon, but our methyl group isn't until the third carbon. So we're going to go with the red numbering system, since it has both a double bond and a methyl on the second carbon. When we name this, we're going to start with our substituent groups, our methyl groups. There's 2 of them, so di-methyl. They're occurring on the second and the 5th carbon. So that's where those numbers come from. Then we'll say 2,5-heptadiene. Again, notice the di comes before the ene. The ene tells us there's double bonds. The di tells us there's 2 of them. Here they are, 1 and 2. They're on the 2nd and 5th carbons. So 2,5-dimethyl, 2,5-heptadiene. These 2,5 go with the double bonds. These 2,5 go with the methyl groups. Some more examples. And right away we should notice on this top one here, there's a carboxyl group. So we have a carboxylic acid. That's going to immediately make this carbon right here number 1. 2, 3, 4, 5, 6. And again, there's our double bond between the 3rd and the 4th carbons. So we go to name this. We'll call it 3-hexanoic acid. Excuse me. So the E refers to that double bond there. The 3 tells us that it starts on the 3rd carbon. That's where the double bond starts. And then we have the oic acid. Again, no number is necessary for the oic acid. It has to be terminal. Again, that means on the end, which means it has to be on the 1st carbon. We'll move we'll move down to this funky looking structure on the bottom. Okay, we've got a lot going on, and identifying the longest continuous chain might be the most challenging part here. I know I have a triple bond, so we'll have to start by getting that triple bond in the lowest possible numbering system. So I'm going to start down here. 1, 2, 3, 4. I'm going to go to the right because I know that chain, either one of those chains, is going to be longer than going up to that single methyl. So 5. Before I continue, I see the 2 carbons up here, 2 carbons down here. It looks like it's going to be the same direction, same in either direction. So we'll just go ahead and go down 6, 7. All right, looks like we're working with a heptyne. Let's identify the branches then. The methyl branch up here on the 4th carbon, and an ethyl branch down or up here on the 5th carbon. So when we go to name this, keep in mind, alphabetically, ethyl should come before methyl, even though the numbers are out of order. So we'll call it 5-ethyl, 4-methyl, 2 refers to the ine, that's the triple bond. It starts on the 2nd carbon of our 7-carbon chain, heptyne. So 5-ethyl, 4-methyl, 2-heptyne. Remember, hyphens between numbers and letters, and commas between numbers. All right, finally, we'll move over to this 3rd structure here on the right. So here I see a double bond here and a double bond here. Again, our longest continuous chain I can already see would be from left to right or right to left and would include this ethyl group. But I want to make sure that my double bonds are on the parent chain. So I'll start up top. So 1, 2, 3, 4, 5.
Might say you're dying to number that one.
So that's going to leave an ethyl group here coming off the 2nd carbon. On the 1st carbon, we had an ene, an E, a double bond. On the 4th carbon, we have an E, a double bond. Again, we'll use the prefix di to signify that we have 2 of them. The ethyl group is on the 2nd carbon. 1, 4, pentadiene. Again, the 1 and the 4 are telling us that those 2 enes, those 2 double bonds, are on the 1st and 4th carbons.